This is the 2019 higher level question B1 looking at axonometric projection. The image on the right shows a package for Dorito tortilla chips. It's based on a regular hexagonal prism which has been shaped as shown. Figure B1 shows the incomplete diametric projection using the axonometric axis method of the package. The plan and elevation are shown in their required positions. There are four parts to this question. Part A is to draw the axonometric axis X, Y, and Z and the isosceles triangle ABC. Part B is to draw the plan and elevation orientated as shown. Part C, draw the axonometric projection of the portion of the package as given. And Part D is to complete the remainder of the package in the axonometric projection. So as it says in the second paragraph, it's diametric projection, and it also says isosceles triangle. Two of our angles are going to be the same. Our y-axis is vertical, and that stays vertical in all of these questions that we do. So we're going to have an angle of 115 degrees between the x-axis and the y-axis, and also 115 between the z and the y-axis. So for this question, I have set my page up in portrait. As I'm using an A3 page, it's a little bit too awkward a size to fit on the landscape version of it. If you're using an A2 page, you won't have any problems. So I've set up my y-axis currently, and I've marked a center point here, that's point O. And I've also then measured 115 degrees from either side. So 115 degrees this way, and 115 coming from the y-axis down to this axis, which is the x-axis. So you got x, y, and z. So we're going to find next the isosceles triangle ABC, and we're told that the distance from B to C, if you look down at the very bottom of the question, is 120 millimeters, which means it's 60 millimeters either side of the axis. So the isosceles triangle is going to be formed now, coming up along this way. To do this, it is always taken as perpendicular to the axis. So this is BC, which is perpendicular to the y-axis. So it's perpendicular here. To find the line AC, that's going to be perpendicular to the z-axis. So this goes perpendicular to this here. And the same thing applies then for the line AB. That is going to be perpendicular to the x-axis. So that completes the isosceles triangle ABC. The line AC is perpendicular to the z-axis. The line AB is perpendicular to the x-axis. And the line BC is perpendicular to the y-axis. So that completes the first part of this. Second part of this is to draw the plan and elevation orientated as shown. So we're going to draw the plan, and the plan is going to be positioned directly below and is going to have the full width of BC. So project our lines down, and let's keep it as low as possible on the page as we can. So I'm going to put it down here somewhere. For all our axonometric projections, we need to draw a semicircle. So that semicircle is based on the full width of this here, and usually we need to bisect this line, but this is already halfway because it's isometric or diametric. We can just use this center point. and there's our semicircle. So from where the semicircle intersects the line coming from the y-axis, that's going to be part of our 90-degree bend. So we're going to draw this line coming out this way, and this one coming out through the other side. So what we're going to do next is we're going to draw the outer hexagon, which is the dark lines. So it's 20 millimeters onto the first point, a side length of 40, and then 20 again. So this here is one side of that hexagon. It will be the same on the opposite side. We don't have quite enough information for that just yet, but we do know it's going to be somewhere along those two lines there. Now if it's a side length of 40, all sides are going to be the same. And the reason I know that all the side lengths are the same is because it says in the question it's based on a regular hexagonal prism. So copying that distance of 40, going to mark a side length here from this point until it touches that axis, this line coming down along here, and then come back in again, marking 40 going this direction. So that'll give me the opposite side of that over here. To get the point down here, this and this are going to be parallel to each other. So this is one side. And then finally I have one more point that I need to locate in here, and that's going to be 40 millimeters away from both. And it's also out to this distance of 20. All work the same. So we can darken in that outline. That's the outline plan. The next part of this is to find the hidden detail plan, the bit for the piece in the middle, and that again is going to have the same side length, and we can see from this piece on our question that it is equal length, so it's halfway along it. Each line is 40 millimeters long, so half that, 20, is the point, the vertex of each of these corners. And that completes the plan. Next part of this is going to be drawing the elevation. Elevation is set up in the same way that the plan was. So we're going to have to project lines parallel to our z-axis, in this case. Lines project out along here from both points A and C. And out along here we're going to pick a point that will form our semicircle. So our semicircle needs to go from this point to this point down here. And to find halfway we need to bisect that line. So drawing our semicircle, and where our semicircle touches the line coming from the axis, the same as what we've done in all the previous questions, that point joins to the diameter points of the semicircle. So to here, and back across this way also. They're the edge view of our planes that we're going to be working on. Now if you notice in the question, we're not given a height for the top of it, but if you look closely you can see that the top of it does touch off this point here. So we can use that information to help us. So what we're going to start doing now is the width of this is going to be based on this width here is going to be based on the width as in looking in this way. So it's 20, 40, 20. So you can mark that up here. So 20, 40 and 20. Lines are going to be parallel to this edge here, as that's considered vertical. So that gives us the top point. We're also told that it comes down 20 millimeters and up 20 millimeters, so we can mark that part into it now also. So the next part we need to figure out is the distances that points come in along here, their positioning and what happens with them. So one part of it is straightforward. We get triangles here in the center that they are found by joining this point down to this one, and vice versa, this is going the opposite direction. Locates this point here in the middle first. We need to find the points that are out here. If you notice, they're not in line with the ones coming down here, they're out here somewhere. So we need to locate where they are. To do that, we need to use a view where we already have that information, and in that view is the plan. So in the plan we can see the distance from the center out to this point down here, and same going the opposite way. So our center point, this point here is here. How far is it from this point out to in line with that? We need to work that out. So if we measure across them, the distance here is 60. So that's going to be 30 millimeters either side. So I can measure 30 millimeters this side and the opposite side. And that locates those points that I'm looking for. So the point that we're looking for in the question, so if we look at the question again, in the elevation you have those 2 points that tuck in on either side. They are point views of the line that we see in plan. So they are point views of these lines here. So the point that we've located here is a point view of that line. So I can find that by joining, after we put in our 30 millimeters, You'll also notice that if you join this point to this one, and here to this point, they give you the same shape. Which is 20 marks of the 45 that are available for this question. So now we're going to have a look at part C, which is draw the axonometric projection of the portion of the package as given. Now this is only 4 marks, but you need to do it anyway, so it's just helping us get into the question, I think. So we're looking for this front portion of it here, which is this side of it here also. So we're going to have to project lines vertically up from the plan and then bring them down at the same angle as the z-axis to get the remainder of it. So I'm going to take these 2 points up, and we'll take the center point of it also, where the 3 lines, which would be here. Now, with those lines projected up from plan, we can now take them from the elevation. So each corner, each point is projected down, so that's this one. And the outside one also. So that gives me this point and this point. And they should be parallel to this, which they are. Gives me the bottom of them. To find the top points, we're going to take here and here. And then we also have the points up here, up on top, so finding the same front face as we found on the bottom, this time up top. So that's 1 point, and the second one here, and then the top out of that face also. Final part then is where these triangular faces, and we can just join the diagonals to get them. And if we're to bring this point down, that'll line up with this point down here also. So that's part C of the question. Part D then is just to complete the remainder of the package. So what we're going to do is I'm going to do the base first, and then the top of it, and then we'll look filling in the bits in the middle. So again, projecting our lines down from the elevation, projecting those same lines up from the plan. So that's this corner down here, and take it all the way up because we're going to need it up on top as well. So that gives me this point here and this one. And I think it's important that you darken lines in as you go. It just makes it a little bit easier, so as you don't get confused about what's what. Now we need the same points up on the top of this. So I'm going to complete the top hexagon now, projecting my lines down. So this corner, and then finally just these back 2 points, we already have the lines that they belong to, here and here. So following that corner from here, and that intersects with this one, that gives me this point. Same for this one coming this way. Coming down this direction gives us this line, and then joins up to the front. We also need to find the lower point of that same one, so that's also on this line coming down this way, giving me that point down here. Now there's just one more to do down at the bottom, which I think we can see. So that would be a line coming from here, giving me that point, and the corresponding one down underneath it is that one down here. So that completes the base, and now what we need to look at is the hexagon part, the triangular faces in the middle of it. And for this, it's just trying to picture what it looks like is the harder part of this. What I'm going to do next, I'm going to find, we have the front face, the two triangular faces here. So there's two more triangular faces going the same direction, joining from this point to this point. So I'm going to try to locate that point in the middle. So that triangular face starts here, which would be there, and then it comes to a point here in the middle. So that's this face. So that's looking at this one, starting here and here, trying to locate that point now in the middle. So that comes from this point. It's located halfway between each one. So we can find that. And try to use your axis always to line this up, just so that you're always coming back to the same point. And that gives me this point here. So that's located from the middle of this and the center of this one here, brought down to intersect. Gives me a line going from this point off up to here. Now you could just join diagonal to diagonal, that will work too. Which will also give me diagonal to diagonal on this one. So you don't really need to go locating the points in the middle if you don't want to. And then we'll have the same on this side. So this one is a little bit trickier because we don't have where they're joining to, so we'll come back to that one in a moment. Now this is two triangular faces, so this needs to split across the middle. Same on this one here. And then we just have one more face, or two more faces to locate, which are found in here. So if we had the 2 points for our hexagon, we could do it that way. We don't, as in if we have the point down here and the point back in here somewhere where the other side of the hexagon is, we could locate them that way. What we'll do instead is we'll take this corner and project that down. So again, lining it up with the axis line. This line comes down along here, so it's going to be somewhere on that line. Where it is going to be directly above where it is in the plan. So that's this point projected up. Locating it, giving me that point there. So to find that now, this joins to this corner, which joins to this one up here also. And then we just have the line splitting the two faces across the middle. That completes this question. This is the 2019 higher level B1 Axonometric Projection. Overall, a fairly doable question.